Okay, this is exam 3 for physics 202. Which of these resistors has the smaller current? Well, imagine my current comes along here. All of it's going to go through R1, so R1 can't possibly be the answer. And then here it's going to split into 3 pieces. Now let's see the options I have. I have R2, R3, and R5. So I want to know which one has the smallest current. Of these, R2, R3, or R5, the one with the smallest current is the one that's in the branch that has the biggest resistance. I have 4 ohms here, 6 ohms here, and 1 ohm here. That means the least current is going to go through this branch because it has the biggest resistance. So the answer then is C. Which has a bigger resistance, a hair dryer or a light bulb? Okay, well, both of these operate at the same voltage. And so I'm going to be going with this expression, P equals V squared over R. Both have the same voltage, so the one with the smaller resistance, if this is small, that means the power gets big. I'm looking for the one with the bigger resistance. So the one with the bigger resistance has the smaller power. So the bigger resistance device is the 100-watt light bulb. You can think about this in terms of, too, the amount of energy that it's putting out, right? The hair dryer is putting out a lot more energy than the light bulb. That means that it has to have more electrons flowing through it. And if it has more electrons, that means that the hair dryer has to have the smaller resistance. Okay, so the answer then would be A. What is the current in the 6 ohm resistor? Well, both of these have 18 volts. So current is V over R. That's 18 over 6, or 3 amps. Current has what basic SI unit? So let's see, coulombs per second, charge per time. Which of these rules for resistors in parallel is correct? Resistors in parallel must have the same current. That's not true. They must have the same voltage. Okay, so 2 is right. The total voltage across the resistors is equal to the sum of the voltages across the individual resistors. That's not true either. That's true for resistors in series, but not for parallel. The equivalent is always smaller than the smallest resistor. That is true as well. So 2 and 4. So number 5 is C. Which of these statements about household circuit is true? It's a parallel circuit. Operate at the same voltage. As you add more devices to a household circuit, the total current increases. That's true as well. The circuit breaker turns off if the total current exceeds some predetermined value. That's true as well. So C is the right answer. Consider the circuit. Which of these equations is correct? Okay, let's look at it. I've already given you the directions here. I1 plus I2 plus I3 is equal to 0. Let's just pick a junction. I1 and I2 are entering that junction. I3 is leaving that junction. So A can't be right because it should be I1 plus I2 equals I3. 3 plus minus 2I1. So it looks like I'm starting here and going in this direction. 3 minus 2I1, good so far, plus 6 minus 6. Well, you see, I don't go back to where I started, so that's not right. So B is not correct. 5 plus 6I2 minus 6. So going in this direction, 5 plus 6I2 going against the current, minus 6. Okay, that is correct. So C is the right answer. Let's go and look at this one. 3 plus 2I1, positive 3. Oh, this should be minus 2I1 plus 5 plus 6I2. That is correct, except this should be minus right here. So D is not right. So C is the right answer. Which of these shows the voltage versus time for a charging capacitor? Okay, well, the voltage increases for a capacitor as you add more charge to it. So I can get rid of this one and this one. The voltage versus time. Actually, let's see. Let me, hold on a second. Yeah, I think I'm going to rewrite this question, so you'll probably see a different question on this. But let's say instead of saying voltage versus time, let's say instead I'm looking at the charge versus time. And the charge versus time will be B. I have an increase in my charge as it charges that capacitor. So number 8 I'm going to change, and I'll make a charge versus time. Which of these statements is true? Magnetic monopoles do not exist. Opposite poles of a magnet attract. All permanent magnets are ferromagnetic. That is true. So D, all of these is true. Which of these statements about magnetic force is true? Magnetic force is a centripetal force. Actually, I'm going to drop this question. I'm sorry for that, but I'll drop it. I might replace it with another multiple choice. I'll come back to you on that. The Earth's magnetic field plays a role in which of these atmospheric phenomena? Uh, Mirages, or excuse me, no. You know what, guys? I'm sorry. I'm going to drop that question too, because we hadn't really gotten to some of that stuff. What is the initial direction of this positively charged particle when it enters a magnetic field as shown? Okay, well, V is to the right, so index finger direction of V. Magnetic field is down, so it looks like it goes into the page. So the force is into the page. So A is 12. Positively charged particle and the magnetic field is shown. What is the force acting on the particle? So here I have V. Looks like it's going to be out of the page. 13 is B. Index fingers in the direction of V. Middle finger in the direction of B. Thumb of your right hand is the direction of the force. Figure shows the path of the charged particle. Negatively charged particle. What is the direction of the magnetic field that has caused this motion? Well, my velocity vector is in this direction. My force vector is in this direction. So that tells me the magnetic field, if I do my right-hand rule, the magnetic field is into the page. However, it is a negative particle, so it should be out of the page. And here a proton enters electric field. What must be the magnetic field such that the proton will go undeflected? So this proton will go through without being deflected. The electric force is in the direction of the electric field. The magnetic force then has to be equal but opposite in that direction. And so I'm looking at a velocity vector in this direction, a magnetic force vector in this direction. What is the magnetic field that causes that? Out of the page, looks like. So C is the right answer. The magnetic field is out of the page. Okay, calculate the three currents in the circuit. And then if you want 5 points extra credit, you can solve it by using this row reduction technique. All right, let's go ahead and write some directions. I'm just going to give us some directions. That is a little harsh, isn't it? All right, so I1 will take to the left, I2 will take to the left, I3 will take to the right. You might have chosen something different. Write my two equations. I'm going to use the top loop, the bottom loop, and the junction. Top loop, I get 3 minus 2I1. That's starting right here. I get positive 3 minus 2I1 plus 5 plus 6I2. That's equal to 0, so you get plus 5 plus 6I2 because I'm going against the current, and then I close that loop. Now also let's do the bottom loop. The bottom loop, I'm going to start right here and go in this direction. So I get 5 plus 6I2. It's just like I had before. Coming down here, minus 6 equals 0. And then I'll do my junction rule. You only have two junctions, so I just pick one. I'm going to pick a junction over here. Incoming currents are I1 and I2. They're coming in here and here, and then I3 is leaving, so this would be I1 plus I2 equals I3. Pretty simple system of equations to solve. I solve this one first for I2. I plug it in here to find I1, and then I plug both in here to find I3. I'm going to rewrite them just a little bit though, just to sort of get us set up for row reduction. I'm going to write them minus 2I1 plus 6I2 plus 8. Or rather, plus 6I2 equals negative 8. 6I2 equals 1. And I1 plus I2 minus I3 equals 0. Again, I'm just getting them set up for row reduction here, but you have to do some of this anyway. I'll call this equation 1, equation 2, equation 3. Let's go ahead and solve equation 2, and I get I2 equals 1/6 amp. It comes out positive, so I'm going to write in my I2 here as 1/6. It comes out positive, so my direction that I chose to the left is correct. Then I will plug that into equation 1, and I get minus 2I1 plus 6 times 1/6 equals negative 8. So these cancel, leaves me with 1. I get I1 equals 9/2 amps. So I1 I can put up here as 9/2, And it looks like I chose I1 direction correctly, so it is to the left. You may or may not have chosen those correctly. And then I'll plug into equation 3. I1 plus I2 equals I3, so that's 9 halves, or I1 plus I2 plus 1/6 minus I3 equals 0. That should be a 3 right there. And I solve this for I3, and I get I3 equals 14/3 amps. Okay, that's 18/6 plus 1/6, or excuse me, 27/6 plus 1/6 is 28/6. That's 14/3. Now, let's go ahead and do the row reduction. This was not required, but you got 5 points extra credit. So just to show you this, I'm going to write my 3 equations, which I've already put in nice form here, I1, I2, I3 form. I'm just going to write that in matrix form. All right, so I get -2, 6, 0, -8, 0, 6, 0, 1, 1, 1, 1, negative 1, 1, negative 1, 0. That's my first one. My first step is just, I'm going to take row 2, I'm going to divide it by 6. I get 0 divided by 6 is 0, 6 divided by 6 is 1, 0 divided by 6 is 0, 1 divided by 6, of course, is 1/6. I got 1, 1, -1, 0. Once you get one of the rows in identity form, the other 3 follow pretty quickly. I'm going to take row 1 and replace it with row 1 minus 6, row 2. Okay, and it'll look like this. Row 1 is going to be -2 minus 6 times 0, so it's -2. 6 minus 6 times 1, so it's 0. 0 minus 6 times 0. And then I have this -8 minus 6 times 1/6, or -8 minus 1, which is -9. 0, 1, 0, 1, 6, and 1, 1, -1, 0. Now I'm going to divide row 2 by -2, or excuse me, row 1, divide by -2, and I'll get 1, 0, 0, 9 halves, 0, 1, 0, 1, 6. So see, I already have I1 and I2 there, and it's correct as I did it by substitution. Now I got to deal with that row 3, and you might have combined some of these steps, and that's okay, but I'll just do them step by step. To get row 3, I'm going to replace row 3 with row 3 minus row 1. Row 3 becomes row 3 minus row 1. Row 3 minus row 1, 1 minus 1 is 0, 1 minus 0 is 1, -1 minus 0 is -1, and then 0 minus 9 halves is minus 9 halves. And now I'm going to do row 3 becomes row 3 minus row 2. So now I get row 3 minus row 2, so it's 0, 0, -1 minus 0, and then this becomes -14/3. There's still another step, I'm just going to make these two positives. Multiply that row by -1. And then there's my currents, I1, I2, and I3, which are in the augment for this, this matrix. That was extra good. Pick one of the safety features in your electrical systems in your home. Write 2 to 3 sentences. We know we had our GFCI, and I was looking for protects user from electrical shock. And then you also need to have some idea that it's measuring I in and I out and trying to fill this requirement. I wanted it in a sentence form, but so you could say the GFCI protects the user from electrical shock in wet situations, for example. And it measures I in and I out. If I in exceeds I out, the device turns off. For a circuit breaker, this protects the circuit from too much current. So it protects you from too much current and the subsequent fires that could result from that. Your wires or system could catch on fire. And it turns off if I exceeds some maximum current value. So 15 amps, 20 amps, 30 amps, 60 amps, whatever it is, your circuit breaker will turn off if your current in that circuit exceeds that value. And then that third prong, or the grounding, whatever you wanted to call it, was fine. It protects you from a faulty device, protects the user from a faulty device, provides an alternate or clear path to ground. For electricity or for current. So instead of going through you, it goes through that wire outside of your house. Could have drawn some pictures if you want, that would have been fine too. Okay, here you gotta do the cross product here. F equals QV cross B. Should be a big surprise you had to do this. 2 coulombs. V is 2I plus 3J. B is 3J minus 2K. Do my foil first is 6I cross J. Outer is minus 4I cross K. Inner is 9J cross J, but J cross J is 0, so I'm not going to write that. And then the last is negative 6 J cross K. Being very careful that I get the order in my cross products correct, because if I get my order wrong, this line will come out wrong. Remember my coordinate system, I, J, K, and then I need to do these three, so I cross J is positive K, I cross K is negative J, and J cross K is positive I. So this comes out carrying the 2 over to all of these. I get 12K. It's positive 12K plus 8J minus 12I. That's my force vector in vector notation. I didn't have to find the magnitude and direction. Find the voltage and current for each of these resistors. Oh, was this similar? I think this might have been similar to what I had before. Alright, so let's see. I have a 2 and a 4. That becomes 6 ohm. And a 3 and a 6 becomes 2 ohm. Let's just go ahead and draw that. So I have 12, 2 ohms, 6 ohms, 2 and 1. 6 ohms. You didn't have to draw this, but I find it very helpful if you do. I find it helpful when I do it anyway. The 2 and the 1 combine to become 3 right here. And then the 3 and the 6 combine to become 2. So my final circuit are two 2 ohm resistors and 12 volts right there. Now, if these are 2 ohms, I have 6 volts here and 6 volts here because they split evenly that voltage from the 12 volt, only because they're identical resistors and so they split it. So I have 6 volts over here. If I have 6 volts on this resistor, I have 6 volts up here, and then I have 6 volts here. Alright, so let's start transcribing these. So R1 has 6 volts. I have 6 volts up here, and then I also have 6 volts here across this whole thing right here. Now, if I have 6 volts here across combined 3 ohms, that means I have 2 amps through that branch. So I have 4 volts here and 2 volts here. So I have 2 volts here, that's the 1 ohm resistor, and I have 4 volts here and 4 volts here. Because they're in parallel, they have the same voltage. Now up here, I have 6 volts. In a similar way, I have 2 and 4, that's 6 amps, 6 ohms. So I have 1 amp here, 1 amp here. So I have 2 volts here, 4 volts here. There's some different ways you could have thought about this, but I think that's probably easier. So let's see. R1, just getting those into the table. 6, 2, 4, 4, 4, and 2. And then I can find my current, if I haven't already, as V over R. It's going to be 3 amps, 1 amp, 1 amp, 4/3 and 2/3. And here is 2 amps. I was looking for a couple of things here. I was looking, well, first of all, these two currents have to add up to give us this current. R2 and R3 should be the same currents. R1, the current, should equal the current in R2 and R6. So R1 should equal the sum of R2 and R6. So I was looking for particular relationships there if you didn't get the numbers right, but hopefully you just get the numbers right. Okay, just a couple more. Here, what is the time constant for the circuit? Tau is equal to RC. The resistance is 2 mega ohms, 5 microfarads. So that's equal to 10 seconds. The mega and the micro cancel out. What is the current after 5 seconds? Well, my current is I naught times e to the minus t over RC. I naught is V over R. That's equal to 10 over 2 times 10 to the 6 ohms. That's the mega ohms. If you didn't get that, I wasn't too much of a stickler for it. E to the minus 5 over the time constant, which we've already found is 10. And this works out to be 3 microamps. 3 times 10 to the minus 6 amps. C, how long does it take to fully charge the capacitor? That's 10 times the time constant, which is 100 seconds. What is the charge at 100 seconds? Well, this is just Q equals CV because it's fully charged. CV is 50 microcoulombs. C times V is 50 microcoulombs. And then draw the charge versus time. If I draw charge versus time, it looks like this, and it's approaching 50 microcoulombs. Okay, one more. Here I give you current and voltage, and the area and the length, and I want to know which of these is the unknown material from the resistivity. I know that R is rho L over A, so rho is RA over L. I want to find out what my resistance is. My resistance is V over I. Here is V, here's I. That's going to be 0.07 ohms. So I get 0.07 ohms times the area, which is 7.85 times 10 to the minus 7 meters squared. It's already in SI units. Divided by the length, which is 1 meter, and then that gives me a resistivity of 5.5 times 10 to the minus 8 ohm meters. That's going to say tungsten. So I was looking for that word that you can select out based on the resistivity. You can select out that it is in fact tungsten. All right, there's the multiple choice, though. Remember, I'm going to change a few of those and probably remove them and not replace them.